So we now have logic and proposition. So what do we mean by logic? Logic is a study of consequence. It's a study of what makes an argument good or bad. So let's define first some important terminologies. So we have an argument, that's a set of statements, and it is composed of the conclusion and the premises. So one conclusion and there might be two or more premises. So an argument is said to be valid if the conclusion must be true whenever the premises are all true. All true, take note. An argument is invalid if it is not valid, of course. It is possible for all the premises to be true and the conclusion to be false. So that makes an argument invalid. So for example, if Edith eats her vegetables, then she can have a cookie. Edith eats her vegetables, therefore Edith gets a cookie. The next example, Florence must eat her vegetables in order to get a cookie. Florence eats her vegetables, therefore Florence gets a cookie. So if you're going to compare the two examples, in this example is not valid because it states here that Florence must eat her vegetables in order to get a cookie. So it is a prerequisite for Florence to get a cookie. While earlier, it's just if Edith eats her vegetable, then he can get a cookie. So Edith eats her vegetables, then therefore Edith gets a cookie. So there is the earlier example is a valid statement. So when we analyze logical statements, we have to be very careful when on how these statements are being constructed. So this part here makes the statement invalid. So a proposition is simply a statement. A propositional logic studies the ways statements can interact with each other. And it is important to remember that propositional logic does not really care about the content of the statements. So let's have some logical connectives or operators. These are very important when we will be applying these in the examples. So we start with logical negation. So the negation of a statement with a truth value that is exactly opposite of the original statement. So it is written either this one or this manner. So if you have difficulty writing the squiggle line, then you may have this way of writing. So that is read as not P. So let's say she is what example can we give? She is a student. So she is a student. This is our P. So if our P is she is a student, how are we going to uh, write our negation? So we just simply write she is not a student, right? So that makes the statement opposite of the original. The next logical connective or operator is called logical conjunction. So a conjunction is a type of compound statement that is comprised of two prepositions, so also known as simple statements, joined by the uh, operator and. So it is being written in symbols, that is written as inverted V. So read as P and V. So P and V. So this is the truth table for the logical conjunction. So you have P and Q, and then we have here P and Q. So if P is true and Q is true, therefore P and Q is true. So we have to take note that in conjunction, if the premise are both true, then the conclusion must be true. If one of them is false, then our conclusion will be false. So if you take note, even if one of the premise is true, it will still give us all false. That's for logical conjunction. For logical disjunction, it's still composed of two statements and and that is joined by the operator or. So this is just in symbols the inverse. So it looks like a V. We read this as P or Q. So for our truth table, what is different here from conjunction is that if at least one is true, then the conclusion will be true. So if we take note, this one both is true, both premise is true. Here for the second and the third, only one is true, but that will still make the conclusion true. If both are false, then of course the conclusion will be false. So the third one, no, the fourth one, a logical implication or conditional statement. A type of statement that is formed by joining two simple statements with a logical implication, connective, or operator. So, in symbols, that is being uh, shown in this symbol. How do you call that? uh, a one-headed arrow. So, our P is known as the hypothesis, then and our Q is the conclusion in this uh, implication or kind of. So we read this as there are several ways of reading this. So we can read it as P implies Q. If P, then Q. P only if Q. Uh, if P of P is sufficient for Q, Q is necessary for P. Q follows from P. Q if P. So we can read it in different ways. And like in the previous examples, that there's only one way of reading them. No, the previous logical connectives and operators. So our truth value here for the conditional statement, so we have if T, if P, then Q, so it's true. If here we have false, so the only false statement here is the second one. So the next, this is the fifth, logical biconditional or double implication. So a double implication is a type of compound statement that's formed by joining two simple statements with biconditional operator. So it is a combination of two conditional statement and its converse. So the symbol being used here is a two-headed arrow, and we read this as P if and only if Q, or we can also P is also known as the antecedent, and Q is known as the consequent. So for our truth value, if P then Q, so we have here the truth value. If both are true, if both have the same truth value for the antecedent and the second one, the Q, then it will be true. If one of them is false, then it will make the statement false.